Good day, students. Welcome to math.serve.com. This is part 2 of our TI89 Skills for Calculus series, and we're going to be focusing on how to use the Texas Instrument 89 calculator to evaluate limits. Don't forget to visit our website at math.serve.com for access to a wide variety of tutorials ranging from algebra all the way to calculus. All right, so how do we find or evaluate limits using the TI89 titanium calculator? The first thing I'd like to talk about is the syntax, okay? How do we communicate the limit that we want to evaluate with the calculator so that it can evaluate it accurately? All right, so I'm going to show you a shortcut that you can use to find what the syntax for evaluating limits is with your TI89 calculator, just in case you forget. All right, so our angular mode is set in radians, so you want to keep that in mind. What I'm going to do is I'm going to go to my F3 menu. F3 gives you access to a lot of functions for calculus. You can see the first one is differentiate, part 1 of our series on TI89. We went over how to find the derivative of a function using that option right there. We're going to be focusing on option 3 this time, which is the limit. And then later on, we'll talk about integration and the rest of them. So how do we enter the limit in the calculator? So let me show you where you can find the syntax to all the functions in this calculator. What you do is you go to the catalog and you search for the function that you want to find the syntax for. Okay, so you press catalog and we're looking for limit. All right, limit is already highlighted for us. So if you look underneath here, it tells you what the syntax is. It tells you enter the expression, the variable, the point that you're approaching, and the direction that you're approaching. Okay, so let's go ahead and write down what the syntax is. So first of all, we're going to be evaluating the limit, parentheses, and then we'll enter the expression, comma, the variable in the expression, and then we'll enter the point that that variable is approaching, and then we have the direction. Is it from the left or from the right? Now, just a few things to note about the direction. If you're approaching from the left, all you do is you put in a negative number, any negative number, okay? And if you're approaching from the right, you put in any positive number, okay? If you just put a sign in there, you get a syntax error, all right? So direction is simply a signed number, and what this function will do is it will extract the sign of that number. It pays no attention to the number, just the sign. I'll show you an example when we're doing number 3. So let's go ahead and try out some problems. Number 1, we're to find the limit as x approaches 9 of the square root of 6 plus 2 root x. All right, what I'm going to do is evaluate this limit manually first, and then we're going to, I will show you how to do it using the calculator so we can see that our answers are in fact correct. Now you have a radical here. Do you have to rationalize? The answer is no. You don't rationalize or do any manipulation to your expression until you first do a direct substitution and ensure that it's an indeterminate form. So is this going to result in an indeterminate form? There's no way we can know until we plug in the value that x is approaching. All right, so let's go ahead and do that. So we plug in 9. We will have the square root of 6 plus 2 root 9. All right, so let's simplify this expression. We will have the square root of 6 plus root 9 is 3. So we have 2 times 3. This becomes the square root of 6 plus 6, which equals the square root of 12. And then if you simplify that, this is 4 times 3, which is 2 root 3. Okay, so that's our answer. Now let's evaluate this limit using our calculator. So press enter limit. Remember the syntax, the expression first, which is the square root of 6 plus 2 times the square root of x. Now we're going to, oops, let me fix that. I had a little glitch with my calculator, so I have to reset it. Okay, so limit as, enter the expression, we have the square root of 6 plus 2 times another square root of x. Now we close the square root for the x, and then we close the radicand. So this parenthesis closes the square root out. Now we've entered the expression. The syntax says we'll enter the variable. The variable is x, and then the point. The point is what is x approaching? And we can see x is approaching 9. There's no directionality here, so that's all we have to enter. Close our parentheses, enter 2 root 3. Now you notice we have this pretty print going on here. It enters the limit in a form that's consistent with what the answer is. If it's written just like this, then you might want to go to your mode and change the view into a pretty print format. Okay, let's go ahead and take a look at another example. Question number 2. What if we want to find the limit as x approaches 2 from the left of 3 divided by the absolute value of x minus 2? If we evaluate this limit by direct substitution, we're going to end up with an indeterminate form. Let's go ahead and do that for you so you just see. So this becomes 3 over the absolute value of 2 from the left minus 2, which equals 3 over the absolute value of 0 from the left. Okay, and then this becomes 3 over plus or minus 0 from the left is negative 1 over infinity. And then when you simplify that, you'll get 3 over plus or minus 1 over infinity, which equals to 3 times plus or minus infinity over 1, and then you get plus or minus infinity. Okay, so what does this tell you? It tells you that we have an indeterminate form. We have two limits that we're dealing with in this situation. Okay, so by direct substitution, that doesn't work. We actually have to simplify this expression and take a look at what direction we're approaching from. All right, so let's go ahead and take a look at this situation right here. This doesn't work. Let's cross it out. Now, since we're approaching 2 from the left side, we know that the absolute value function has two different slopes or signs depending on the direction that you're coming from. If you're coming from the left direction, remember the v nature of this function, the slope is basically negative, right? So we're going to have a negative value in front here. So let's go ahead and simplify this. We'll have the limit as x approaches 2 from the left of 3 divided by plus or minus x minus 2. All right, since you're coming from the left, this becomes the limit as x approaches 2 of 3 divided by negative x minus 2. Okay, so you're coming from the left, so you have to pick the negative as opposed to both of them. Okay. All right, now let's go ahead and simplify that. We can now do our direct substitution because we've resolved the duplicate nature of the signs here, either plus or minus. So we have 3 divided by negative 2 from the left minus 2. That equals 3 over negative 2 from the left minus 2 is 0 from the left. This becomes 3 over negative 1 over infinity. Actually, it is negative 1 over infinity. Simplify that to get 3 over 1 over infinity. And then you multiply the numerator by the reciprocal of the denominator, and then you get infinity. Okay, so you see how painful and involved the process is. Let's go ahead and enter this expression, evaluate this expression with our calculator. Okay, so we remember what the syntax is. You press F3 and option 3, or you can go to the catalog and scroll down for limit. We'll enter this expression, 3 divided by absolute value. You go to catalog, and the first function there is absolute, so you select that absolute value of x minus 2. Close that. Now we've entered the expression, comma, the variable is x, comma, the number we're approaching is 2, and now the direction. Remember what we indicated earlier? All you just have to do is put in a number with the sign of the direction that you're approaching. Okay? So since you're approaching 2 from the left, I can simply enter negative 1. Okay? Now, how does the calculator read this argument? It just reads it as evaluate this expression as x approaches this value as x approaches 2 from the direction of the sign of this number. So it simply extracts the negative piece from here, okay? So you press enter, and then you see what you get there, infinity. All right, another good practice you always want to make a habit of doing is always examine your entry to make sure it's consistent with the problem. Okay, so let's inspect this closely. We have limit as x approaches 2 from the left, limit as x approaches 2 from the left, 3 over absolute value of x minus 2, 3 over the absolute value of x minus 2. Always ensure that your entry is accurate in order for you to be confident that your answer is in fact correct. Okay, let's take a look at problem 3. This is a limit involving infinity. Question number 3. We want to find the limit as x approaches infinity of 2x squared divided by e to the x. Now you can evaluate this limit using L'Hopital's rule if you studied Calculus 2, but for AP Calculus, that's not covered, so we can basically use the growth rate of these two functions at infinity to evaluate this limit manually. Okay, so we know the order of growth rates of functions. We know that one of the slowest functions is a logarithmic function. That is slower than your polynomial function, x to the a, and your polynomial function is slower than your exponential function. So if you look at this situation right here, the exponential function grows much faster than the polynomial function. So at infinity, this limit is the same thing as saying, okay, we're evaluating the limit as x approaches infinity of 1 over e to the x. At infinity, 2x squared grows so slow that we can view it as 1, okay? All right, so let's go ahead and evaluate this limit by direct substitution. So if you do that, we're going to have, this is going to become 1 over e to the infinity, right? So that becomes 1 over infinity. 1 over infinity is simply 0. So this is the limit using algebraic methods manually. Now let's use our calculator to evaluate this limit, okay? We remember what the syntax is. We'll go F3, option 3, enter the expression 2, well, we have to encapsulate the numerator in parentheses, 2x raised to the second power divided by e to the x divided by e to the x, and then enter the variable. The value approaching is infinity, so diamond, let's see, where is infinity again? Diamond catalog will give you infinity. Close it, enter, and your answer is 0. Okay, so let's examine our entry to ensure that we entered it correctly. Okay, so we have limit as x approaches infinity of 2x squared over e to the x. Excellent, and the answer is 0. All right, now let's go ahead and take a look at the last question. So for number 4, we need to find the limit as x approaches 3 from the left of the floor of 3x minus 9. Okay? All right, let's do this manually first, and then we'll use our calculator to figure it out. So we can evaluate this by direct substitution. So we have the floor of 3 times 3 from the left minus 9. Okay? And then this becomes 3 times 3 from the left is 9 from the left minus 9. And then 9 from the left minus 9 is equal to 0 from the left. Okay? And then 0 from the left is the same thing as a number that's really, really close to 0 from the left-hand side on the number line. So an example could be negative 0.001. All right, so if you think about it, 0 from the left, let me give you a visual. You have a number line, and you have 0. 0 from the left is just a number that's infinitely close to 0 from the left side. And we know that this is negative and this is positive on the number line. Okay, so that's why we're using this value. Any value that's really close to 0 from the left will suffice, as long as it's less than is greater than -1. Okay, so what is the floor of negative 0.001? What the floor or greatest integer function does is that it rounds down non-integers. It rounds down non-integers to the biggest integer that's smaller than that non-integer. Okay, so the biggest integer that is smaller than negative 0.001 is -1. Okay, so there goes your final answer. Now let's go ahead and evaluate this limit using our calculator. So we remember what the syntax is. F3, option 3. We're going to enter the greatest integer function, catalog I. So we'll look for int. So int, that's the greatest integer function. 3x minus 9. Close your greatest integer function. That's the end of the expression. And we enter the variable, which is x. The value that the variable is approaching, 3. In this case, there's a direction, which is from the negative direction. So I'll enter -2. All that the calculator reads is the sign of the number. It doesn't care about what the number is. Okay? Let's press enter. Now we have to read the entry to ensure that we entered our argument or expression correctly. Okay? So limit as x approaches 3 from the left. Good. The greatest integer function, or int, they mean the same thing, of 3x minus 9. Good. And we have our answer -1. Okay? So we are confident that our answer is in fact correct. So thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. And do post a comment in the comment section to let us know what you think about this presentation. or to make requests for other math tutorials you would like to see. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.